Okay, everybody. In our last segment of motion equations, we're going to be looking at what happens when an object changes its motion during a problem. So we're looking at an example here. We've got a truck traveling at a constant velocity of 95 kilometers an hour. When the truck driver notices a change in the speed limit, it begins to apply the brakes, but after a reaction time of 1.3 seconds. So that means for 1.3 seconds, this driver was traveling at a constant 95 kilometers an hour. Again, 1.3 seconds. We had a nice uniform motion, or constant motion. Then the truck slowed to a speed of 55 kilometers an hour, so 55 kilometers an hour, and it took a time period of 6 seconds. So obviously what's going on here is we are slowing down. We have a negative acceleration. So you notice I did a little diagram here to help us keep track of the motion for the first part of the motion with its uniform, and the second part of the motion where we've got a negative acceleration happening. Okay, so when we do these problems, you might want to start with a diagram, but regardless, you have to select your positive direction. So we're going to say forward is positive. There we go. And we're going to write down our givens. So here, my velocity is 95 kilometers an hour. And 95 kilometers an hour is going to be, let's see here, 26.4 meters per second. So 26.4 meters per second. And we travel for 1.3 seconds. And we're trying to find the displacement here. How far did we travel during that time? Well, in this situation, because we have a uniform motion, I can actually use the uniform motion equation. Remember, normally we cannot use this. So I'm going to solve for the displacement. So I'll bring that time over, cross multiply, plug some numbers in over here. So 26.4 meters per second, and we're traveling for 1.3 seconds. And that's going to give me my displacement. So let's see what that is. Times 1.3. So we travel 34.3 meters before the brakes are even applied. So that's why it's important to leave a little bit of space between you and the drivers in front of you so you can react appropriately. Okay, so for the second part of motion, what we have here is we're starting with 95 kilometers an hour, or 26.4 meters per second, and we're going to end up at 55 kilometers an hour, or 15.3 meters per second. And this takes 6 seconds, and we want to figure out how far we travel during that component of motion. So we do a little bit of eHarmony equation match, and we end up with our equation, which is 1/2 v1 v2 times time is equal to my displacement. So let's plug some numbers in over here. So my displacement is going to be 1/2 of 26.4 plus 15.3 seconds, or sorry, meters per second, and this is going to happen over 6 seconds. So let's multiply through a little bit here. So we've got 26.4 plus 15.3. I'm going to multiply that by 0.5 because of the half, and then times 6. So we're going to travel 125 meters during the braking portion. So overall, displacement is going to be 125 meters forward plus 34.3 meters. This is 159. You don't need your calculators for this one, folks. And have a little therefore statement. Therefore, the truck traveled. Let's see significant digits. Looks like 160 meters forward. Before reaching 55 kilometers an hour. That's it. So you can see here, just to recap, we drew a little sketch of our motion. The two parts of the motion, we solved one side, then the other side, and we found our total quantity. Okay, let's look at another situation. So here we've got a top fuel dragster. These are those dragsters with the huge wheels in the back, little wheels in the front, massive engines here, and they have these big tail fins over here, the driver's somewhere over here at the helmet, and they go really fast. So this particular situation, we're going from rest to 530 kilometers an hour. That's pretty fast. Okay, so 0 kilometers an hour to 530 kilometers an hour over a distance now, or displacement of 200 meters. And then the dragster releases its chute and comes to a stop. So final velocity here is going to be 0 in 450 meters. So again, two types of motion. Let's take a look at each. So the first component, we're going to have my velocity of 0 meters per second, then my velocity of 530 kilometers an hour, or, let's see what that is, 530 divided by 3.6, 147 meters per second, and this occurred over a displacement of 200 meters. So we're looking for the time it takes to do this. So let's check this out. So again, eHarmony equation, we match up with the most appropriate equation. So in this case it would be V1, V2 times a half multiplied by time. And we're going to solve for the quantities we want. Just put our vector symbols in, I forgot those. All right, let's see what we have here. So 200 meters is equal to 1/2 0 plus 147 meters per second multiplied by my time. So let's see what we can do here. So I'm going to multiply 2 by 200, so 400 all over 147, and this is going to equal to my time. So in this case, 400 divided by 147, we end up with a time of 2.7 seconds. So it takes 2.7 seconds to accelerate from 0 to 530 kilometers an hour. It's pretty impressive, actually. All right, for the second part, we're starting at 147 meters per second, and we're going to end up at 0 meters per second. And this occurs over a displacement of 450 meters. And like before, we're trying to find the time. So a very similar equation we have here. So my displacement is equal to my 1/2 V1 V2. So in other words, my average velocity multiplied by time. Let's see what we got here. So we got 450 meters equal to 1/2 147 meters per second multiplied by time. So 450 times 2, forget that, 147 is going to give me my time. Let's see what that gives us. So 900 divided by 147, and we end up with 6.1 seconds for my time. All right, so let's look at the overall time. So my overall time is going to be 2.7 seconds and 6.1 seconds. So 6, 7, 8, 8.8 seconds overall. So therefore, the dragster was in motion for 8.8 seconds, and we're done. And just like before, just to recap, we drew the diagram, we did the two different calculations for each component of the motion, and we found our overall quantity at the end. And that's it. So that's it for equations, folks. Hope you had a little bit of fun.